Ladies, this is Miss Loden. Sorry I'm not with you today. I'm at home with a sick child. I want you to take out Unit 1, Goal 4 handout. We used this handout in class on Thursday, August the 20th, and we were looking at properties of exponents or using properties of exponents to simplify expressions. So we quickly review. We recall that when we are multiplying like bases, m squared times m to the third power, we add those exponents. 2 plus 3 is 5. In some cases, when we raise to the 0 power, not some cases, in all cases, when we raise to the 0 power, that value is 1. Remember our rule. Any base raised to a 0 power is 1. In numbers 9 and 10 yesterday, when we added the exponents, 3 plus -4, our result was -1. 2 plus -3, our result was -1. And I told you to wait till the next class period to discuss how to make negative exponents positive. Well, it's pretty easy to make negative exponents positive. Let me show you. Let's take the base a, and let's raise that to the -3 power. Well, right now we have no denominator, but remember, to make any number a denominator, we just divide it by 1. Or to make any number a fraction, we divide it by 1. Now I have a way to make this negative exponent a positive exponent. To change any negative exponent to positive, if that negative exponent is in the numerator, we move it to the denominator of our fraction. When we move this base and its exponent to the denominator, that base stays the same, but its exponent changes signs. And essentially, we have canceled out a to the -3. And remember, anytime you cancel, reduces to 1. Let's look at another example. Let's take a to the -1 power divided by 6. And let's make this negative exponent positive. If we use our rule, the 6 does not move because it's raised to the +1 power. Remember, when we see no exponent, we assume that the exponent is +1. So the 6 stays the same. But it's the a that has a negative exponent, so we move a to the -1 to the denominator, and its exponent turns from -1 to +1. Remember, when we move that, it cancels that base and its exponent out, and that becomes 1. Let's do another example. Let's take 2 divided by a to the -3 power times b to the +2 power. All right, so if we analyze each base, we have 2 to the first. It has a positive exponent, so it will stay put. B to the 2 also has a positive exponent. It will stay put. But it's this a to the -3 that has a negative exponent. So we will move this base and its exponent from the denominator to the numerator. And when we move, the negative exponent becomes positive. And this expression cancels out. And notice now we have all positive exponents. So I'd like you to go back to number 9 and pause the screencast and rewrite number 9 so that you have only positive exponents. Remember, pause the screencast, rewrite it, then press play on the screencast again. Let's see how you did. 12 is raised to the first power. 1 is positive, so that should remain in the numerator. A to the -1 and b to the -1 are both negative exponents, so we will move them both to the denominator. And now our expression is 12 divided by AB, and we have all positive exponents. Try number 10. Pause the screencast, rewrite number 10 with only positive exponents, then press play again. Let's see how you did. X to the fifth has a positive exponent. It should stay in the numerator. But y is raised to the negative 2 power, so it should be moved to the denominator. How are you doing so far? Let's move on now to number 12. Let's work this example together. We have 2x squared raised to the negative 4 power. When we have an expression inside parentheses raised to a power, we have to remember to distribute that exponent to each factor inside the parentheses. So when we distribute that, this becomes 2 to the negative 4 power x squared raised to the negative 4 power. Now, up to this point, we have not yet discussed how to raise an exponent to another exponent. You may or may not recall from Algebra 1 that our rule is when we raise a power to a power, we multiply those exponents. Let's jot that rule down. To raise a power to another power, multiply the exponent. Okay, and please make sure you jot that down. So let's go back to our problem. We have 2 to the negative 4, x to the 2 times negative 4 is negative 8. So now we have an expression that is each base is raised to a negative exponent. I would like you to pause the screencast and try rewriting number 12 so that both bases are raised to a positive exponent. Let's see how you did. 2 to the negative 4 moves from the numerator to the denominator and becomes 2 to the positive 4. X to the negative 8 moves from the numerator to the denominator and becomes x to the positive 8. Because both bases cancel, our numerator reduces to 1. Now the last thing we need to do is raise 2 to the 4th power. So let's think that through. 2 to the 4th power is 2 times 2 times 2 times 2. And remember, we're still working on our math brain, so we're not using our calculator. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So our final expression is 16x to the 8th power. I want you to pause the screencast and try 13, 15, and 16. Come back and check your answer when you've done. Now you're ready to check. 13 is equal to 256. Number 15 is 81k to the 16th power, and 16 is 1 divided by 4xy. If you missed any of these, pause the screencast and study the work that I've done for you. For the remainder of the class period and for homework over the weekend, I'd like you to complete Unit 1, Goal 4 Practice Worksheet, Problems 1, 2, 3, and 13 through 16. Complete, check and correct your answers before the next class period. The answers will be found on Haiku on the Unit 1 page. Thank you, ladies, and have a great weekend.